was for hand digit recognition. So I have to recognize the written digits which were captured by a scanner into an image. So the data provided was MNIST data. Both training and test data was provided separately. MNIST data is a very large database where a pixel values of each digit along with its label were captured. So basically there were around 28 into 28 784 columns plus one extra column for the labels. So, and each column had a value from 0 to 256, 0 denoting the light mark and of the pencil, and 256 denotes the darkest. So as a part of EDA, data was checked for any duplicate values or any values, and then finally a near zero variance function was used to remove any columns which had just a unique value or very few changing values. Basically it has the same consistent values throughout all the rows in a column. And finally the data left was normalized. So as a part of data modeling, SVM, which is a support vector machine model, was identified to be used, which is a popular classification model. Though SVM is computationally heavy, so I used only 3000 rows from the actual data set to train the model. First, linear kernel was used for the linear kernel of SVM was used, which uses a hyperplane to separate the classes. The linear SVM gave a accuracy of 90% when using the confusion matrix. And then next RBF kernel was used, which gave an accuracy of 91%. Polynomial kernel was used. It gave the same accuracy as the linear model. Finally, to evaluate the model, cross validation function was used using different hyperparameters. For linear SVM, 3 values of C was used, but it gave a same accuracy of 91%. Then for RBF kernel, 3 different values of C and gamma was used, but the best accuracy we got was 11%. So considering the linear model was giving best accuracy and it's less costlier than the RBF kernel, linear kernel of SVM was used to get a accuracy of 91% to recognize the handwritten digits which were captured by a scanner.